Let me put my presentation on.
So we can't see you.
Yeah, I'll put it on my. Okay, now we can see, right? Can you all see me? Now I have to share my presentation with you. Can you see the slide now?
Yes, sir, we can see.
Okay, then we can start. I hope everybody can hear me and see the screen. Okay. Can everybody hear me and see the screen, please?
Yes, we can hear and we can
Yes, sir.
see.
We can see the screen.
Okay. Okay, then it's time to start. Now, today, our topic is actually, as said, sustainable development and climate change. So I have put it as climate change and sustainable development. You all know nowadays we talk about sustainable development most of the time, and how it relates to climate change is also very important. If you are aware that when the United Nations Framework Convention on Climate Change was initiated in 1992, and every year internationally we have meetings, and then in Rio Plus 20, this sustainable development came into being. In my presentation, you will see all that. And then, of course, you all know the Paris Agreement under climate change. Main purpose of climate change is linking climate change to sustainable development. So therefore, these two are very closely linked, and you will see how the climate change will influence the development. Of course, development, not the sustainable development. Development has created the mainly this climate change problem, and therefore, as engineers, we all have a responsibility to look at this theoretical as well as practically. So I'll be talking about climate change, then the sustainable development, then the linkage between the two, and as a country, our problems associated with this, how we move towards sustainable development from just development, economic development, and also I will highlight some of the points that we need to really think in a practical sense when you are in the field. So that's my aim. So let's start. Okay, now you all know what is climate, right? Climate is long-term average of a weather in a situation or in a country. So for that, according to World Meteorological Organization, you need to have at least 30 years of data, and we talk of climate as the average of this 30-year minimum period. Say it may be rainfall, we talk about temperature, we talk about wind, all that. So it's a long-term average of a weather parameter and the weather. Okay, so long-term average of climate is considered as climate. So, however, there are so many definitions if you look in the internet for climate and climate change. But I am putting here the latest very important definition given by the United Nations Framework Convention on Climate Change, that is UNFCCC. So here you can see that climate change of climate, which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere, which is in addition to natural climate variability observed over a compatible time period. That means there are two components to climate change. One is the natural change, the other one is direct or indirect human activity. So therefore, mainly we will be focusing now, the main factor is actually human intervention, and therefore we need to focus on that mostly. Right, now, if you just consider the factors affecting the climate, there are external factors and internal factors in the Earth atmosphere system. Now, the external factors are mainly the energy input into the system, mainly from the sun. So, solar output, geometry. If you have a dust, then the amount of energy coming into the system will be less, and so on and so forth. And then we cannot do anything. Now, those are natural things. Of course, internally inside the climate, there are things that we can also consider changing if possible. Now, other than that, natural things are like volcanic eruptions will put a lot of dust and gases into the atmosphere. Then mountain building, continental drift, all that will physically affect the movement of air and then the climate. Then surface reflectivity, atmospheric reflectivity, that will contribute towards giving away the energy that is coming into the system. Then mostly the atmospheric chemistry is the one that we need to really think. That is, in the atmosphere there are many reaction, action, and we put a lot of things into the atmosphere. Man-made chemicals goes into the atmosphere, and there are many things in the atmosphere happening that will lead to a lot of climate change actions. Then, most importantly, atmosphere, ozone, heat exchange. Because now, even though the sun is the main heat source for the system, atmosphere mostly gets its energy from the ocean. Because because mostly, I will talk about that also. Our atmosphere is transparent to most of the solar energy, and it goes straight away to the surface. And if you consider the surface of the Earth, mainly it is covered with oceans, especially in the tropical regions, and therefore a lot of energy gets into the ocean, and ocean has a thermal inertia, and therefore it slowly gives the energy into the atmosphere. That's the main way of getting energy into the atmosphere. So therefore, the ocean, atmosphere, land factors are very important. To tell you, actually now there are institutes under this, like something like COLA, Center for Ocean Atmosphere, Ocean Land Atmosphere, COLA. So things are very, very important. And let's go move on to see now. This is also environment. I'm not going to into details, but these are the factors or areas that affect the climate. Now, stratospheric ozone layer is controlling the energy into the system. Now, we will see later that if you deplete the ozone layer, more energy will come and the system will heat up, and also it will be disastrous, and we won't be able to live in this atmosphere, in the Earth atmosphere system, we or any living being. Then, of course, we have the biodiversity, forestry, air quality, deforestation. These things act in both ways, back and forth. If you change the forest course, it will influence the climate, and then the climate change will in return change the forest, growth and all that. Now, the water cycle is most important in this water, mainly because it controls the energy and also the movement of air. Right. Now, what I said here was that if all these factors are affecting the climate of the Earth. So if you decrease, for example, ozone layer is taken off, then more energy will come, and the atmosphere or the Earth will be warmed up, and we will not be able to live, or any living being will not be able to live in the Earth system. So similarly, if you take forest and say air quality, if you change those, the climate will change. And of course, when the climate is changed, for example, forests will be affected, right? More heating means some plants will die. So likewise, all these factors, biodiversity, all that, are related to climate. And if you change those, climate will change. If climate changes, that will affect all these factors. And I was talking about this water cycle, most important. Mainly, it drives the system. And so there I was talking about. This is so important now that, people study water cycle, especially moisture influx, then the water cycle all contributes to the climate, and therefore it's very important. So I will go quickly now to the next slide. This is most important, the very natural climate causes of climate change. Here, I will not talk about natural things. I talked about it before, but my focus is on the anthropogenic greenhouse gases. Those are the things that mainly change the temperature of the atmosphere and which lead to climate change. Now, here we have first three are natural gases: carbon dioxide, methane, and nitrous oxide. Then we have CFC, HFC, CFC, and so on. They are all man-made gases. So they are all in the atmosphere. So the main cause for the climate change is we can consider as. Can you all hear? Hello? Hello?
Yes, sir. Yes, sir.
Can. No, I heard something. All right. Okay. Burning fossil fuel and changing land use, rising livestock, urbanization all leads to more carbon dioxide and methane and other gases in the atmosphere. We reduce the sink absorption of carbon dioxide. If you are clearing the forest, for example, more carbon dioxide in the atmosphere, it will not be absorbed, and therefore it will lead to more concentration of greenhouse gases in the atmosphere. And the forecast is that now we had 280 parts per million in pre-industrial time, but by now it's over 400 parts per million in the atmosphere. So if you have our business as usual, by year 2100, it is projected that the concentration of carbon dioxide in the atmosphere will be minimum 540 to maximum 970 parts per million. So it's going to be a situation where we will be able to live in this planet. So now, what are the reasons of temperature increase? As I said before, quickly I go through this. Urbanization, as you know, then the population growth, the new thing I put here, mainly because if you have more population, then the energy use, more housing, you need more food, and you try to clear the forest and cultivate food, and all that, in turn, increase the greenhouse gas level. Then enhanced income level will you have to have more vehicles, maybe just pure economic development, demand added increased cooling, for example, air conditioning, and transport cooling, cold chains, all that. Then increase energy demand because we need more energy, and then deforestation, as I did before. So, and land, sea, and air pollution increases, and all this leads to the climate change. Then this is just another forecast or the prediction. Now, according to the estimates, temperature will, is expected to rise between 1.4 degrees to 5.8 degrees Celsius during the before the turn of century. Actually, now we can see that. I will show you later some of the increases happening now. Then, of course, with the increase of temperature, you all know what will happen, melting of ice caps, and then, of course, the more water comes into the ocean, and then the ocean temperature goes up, and expansion, all that leads to rise in sea level. And at present, it's about 10 to 20 centimeters. It go up to maybe half a meter by the turn of century, if you go as it is. Now, all this is actually predicted mainly globally, and this is synthesized by Intergovernmental Panel for Climate Change, which is actually a body comprised of thousands of scientists. It is initiated by World Meteorological Organization and UNEP, United Nations Environment Program, way back. So they are doing this, and their estimates are, I'm putting that, this is the source that for these things. So we consider that fossil, burning of fossil is a dominant factor for increase of carbon dioxide in the atmosphere. Okay, this is just to show you how it felt. These are measured values, observations. As you can see, from 1960 to 2010, is going up. This is the carbon dioxide concentration in the atmosphere. Within that increase, you see a annual cycle, very clear annual cycle. That is because now during summertime, northern summer, growth of trees and vegetation, and the carbon dioxide is absorbed, and then the concentration goes down. And when winter comes, it increases again. So that's why this summer-winter cycle, and even though cycle is there, increase is, steady. So by 2010, now of course more than 400 parts per million up here. So that's why now this is from Hawaii Mauna Loa measuring station. I have worked there for some time, so that's why I'm very keen to show you this. Now, there is a very clear connection between carbon dioxide in the atmosphere and the global temperature. So now these 2010, new things are also there. It is going up rapidly in a very steep way. So that's real. Now, this chart, I just want to show you how the natural factors and the man-made components contributed. Now, see, predicted natural changes are a green one. So you can see it is more or less stay going down actually, not increase. Then we have the predicted, some observations are here, the black line, and the prediction. If you add the two, the prediction and the natural changes, you see that is going along with the observed curve. So that means it is very clear that man-made contribution is making this change, not the natural forces. So therefore, we are making this change, and we should be able to manage this if you do it the right way. So that's the main point in this figure I want to convey to you. Now, just we'll look at the input, radiation input in our system. It's coming from the electromagnetic radiation, sun's radiation. So, as you can see, this is the solar spectrum. We have the wavelength and the different type of, we label them as gamma rays, X-rays, ultraviolet rays, infrared, microwave, radio wave, so on. But it is so that depending on this temperature, sun's temperature, it puts out most of its energy under visible light. That's very important and very good, because that's the radiation that we need for keep warm in surface, and also the plants absorb this radiation to grow. But you have ultraviolet rays, which are high energy, short wave radiation, and of course more energetic rays are gamma rays and X-rays. X-ray can go through your body, but bones can be seen in that picture. Controlled X-rays we take. Then gamma rays are more energetic than X-rays even. Gamma rays can go through your bones as well. So if these radiation comes through the Earth's surface, we will not be able to live. The plants will not grow. So on the other side, we have infrared, microwave. We use them for various reasons, broadcasting, television, and all on. So they are not that energetic, low energy. Okay, so this is the amount that is, the way that the energy is coming into the system. Therefore, we just understand how they are working. Okay, now this is a diagram I want you all to know. We always talk about greenhouse gases. What are they? How do we define them? Now, this is the same spectrum wavelength here. Now, if you know, the visible is in this area, right? And then these are different gases in the atmosphere, some of the different gases. Now, if you take, for example, carbon dioxide, now here in the y-axis, we have 0 to 1. That means this is the absorption of radiation by different gases. Now, 0 means no absorption, 1 means total absorption. So if you take carbon dioxide, they absorb radiation in this wavelength region, totally, right? So they are, here and there, then beyond this place. But other places, they will not absorb. Now, methane absorb in this area, nitrous oxide here, and water vapor also absorb. Total atmosphere given here. Now, very important thing is this one here. Ozone and oxygen, they absorb completely 100% all the harmful radiation coming through from the sun, up to gamma rays, X-rays, UV rays, all are absorbed by ozone, which is the ozone layer way up in the atmosphere, maybe 35 kilometers up or so above the Earth's surface, and they completely absorb, and therefore we get only the needed ones, mainly the visible range. That's very important. And we have some what are called atmospheric windows. Here these windows are, for example, radiation comes through and goes out also. Other things are absorbed in this area, right? So this is very important because we need windows. We use these for our these windows for our communication, for example, Earth observation, and many other things. Satellites are focused onto these areas, and then the wavelengths, and then we can see through these windows. If you completely block this, we won't be able to see. Satellite will not be able to communicate. All that is there. So this is very important. So what are greenhouse gases? Greenhouse gases are gases that absorb beyond this visible range, long wave radiation. So that's why these are all called greenhouse gases, and ozone also absorb here, but it's also absorbing here. That's why it's also a greenhouse gas. Okay, so that's just the greenhouse gases in that. Right now, I said this is the main window, micrometer 10 window. Now this is there in the previous one also. This window here, this one. So now what happens if the CFCs and all block that window also? If you have this, then they are blocking, and therefore it's a problem, right? They trap the radiation going out and warm the atmosphere, and also it blocks the radiation going out, and the communication also can be disturbed by this. Okay, now very quickly, the atmospheric layers. Now this is the height in kilometers, and you have temperature on this side. Now global average atmosphere maybe 10-15 here, and as you go up in the atmosphere, temperature decreases rapidly and increases here, and increases. Now why? Now we know it can decrease mainly because your engineers know when the volume increases, the temperature goes down. If it's a covered system. For example, if air coming out of a balloon you will feel cool, right? Air coming up out of a tire will be very cold. You will feel it's cold. But if you try to put air into the tire, it will warm up, right? It is warm because compress, warming, expansion, cooling. So this is the theory actually. So here, as you go up, the pressure decreases in the atmosphere and the air cools. What happens here now? How can it go up or increase with height? This is mainly because of the ozone layer here, lying here, and it traps all the high energy radiation coming from the sun and warms up here. And therefore, we have an inversion in the temperature profile. That is very important too for our weather and climate, mainly because warm air rises, cold air sinks. So it happens only in the troposphere. Beyond the tropopause, air is not rising, mainly because in this layer, cold air here, warm air here, and therefore cold air will not rise, warm air will not sink. So therefore, there won't be any up-down motion here. Stratified layer, and weather is controlled by this tropopause, and clouds like this, giant clouds will go up here only, and afterwards it cannot go up, it goes sideways. So these are called anvil cloud. So this is a big thunderstorm, right? So what happens if you take the ozone layer out here, then there won't be any warming here. This will decrease all the way like this, and the cloud will go up to maybe 80 kilometers or so, and the rainfall will increase enormously, and it will be a real disaster. We won't live. So this is a natural, creation that helps to keep the weather controlled and keep us safe and sound in the atmosphere, in the Earth's surface. So that's why it is very important that we take action to, keep the natural things as it is without destroying them. So why I say that, some of the man-made chemicals are destroying this. I'll talk about it later. So this is what it is, or just for general knowledge. Then, as you know, the greenhouse gases, these are natural greenhouse gases. They are in the pre-industrial era also, but not much, right? These parts per billion now here, not all million. We said 400 million per parts per million now, but it was like 278 parts per million during pre-industrial time. I showed you before. So these are also very, very small quantities, but these were not there at all. But now, 1994 values are there. These are there. Well, yeah, there. And of course, the lifetime is also important. Some of these gases live, man-made chemicals, in the atmosphere, they live 50,000 years or so. So it's very, very important that we should not put this into the atmosphere. They will not be going away. They will be there and heating up. And then look at this now. Global warming, if you take carbon dioxide as one, these things have this much of a potential for warming. 6,200, 7,100, 1,300, 6,500. So all these synthetic gases have very high global warming potential. Here I have given how these things are coming, where these are production, So they are coolant, mainly CFCs, HFCs, coolant, right? Foams, production of aluminium, all that is there. So this is just for your information. Get to know these things well, so that you will take proper action when you do things in the real world. Okay, now this is just to give you an indication how carbon dioxide emissions are taking place from various countries. This is only 1990. There's a reason. This is called the baseline. In order to, these are observations in 1990. Now, with that baseline, we try to reduce. There are, convention. So here, just to leave you now, main emitter is USA, EU, Russia, Japan, and so on, Poland. Those countries are the most, emitting countries throughout. So they are historical responsible for this, climate change. So that's why in the negotiations we show these things and see how we can come up with a remedy. Okay, so then if you take the sectorial, so fuel combustion, carbon dioxide comes mainly for fuel combustion, 63%, and then land use, these two I talked to you, and methane emission, and then agriculture also, nitrous oxide, methane. So those are the areas that greenhouse gases gets into the atmosphere. Now, if you take the temperature change, I said before, by 2100, turn of the century, temperature may go up to 5.8 degrees. So these are all predictions by model. So therefore, the range is because of some models are showing this much, some are showing this much. If you go with the average, maybe about 3 degree, 3.5 degree. That's also a very, very dangerous situation. Right. Now, what we should do. Now, look at, if you, that I said, sea level rise increases, I'll quickly go through this. I have a lot of things to talk about. I will not go into detail, but as temperature goes up, ice will melt and glaciers melt, all this gets into the atmosphere, warmer water gets warmed, thermal expansions of sea water, and that sea level will rise. So this is the percent current rate. Current rate means about 10, 15 years ago, this was the rate, right? About 0.16 inches or 4 millimeters per year. Sea level is rising. Then give you some information. Now, this is the northern hemisphere. sea ice extent. 1950 it was something here. These are 10 to the 6 square kilometers. So by 2000, this is like this. Now, these are also predictions now. By 2050, they'll come down to this level maybe, and 2100 this level. So, in other words, the extent of sea ice will be lowered to this level. That means all this ice will get into the ocean as water. So therefore, definitely, very rapid sea level increase is expected. Now, that's why now global mean sea level. This is also prediction now, different models. As you can see, different models give different values. But however, if you go for the mean, maybe 0.5 to 0.6 meters by 2100, that's the expected level. If you don't do anything, right, this is what is going to happen. So some of the and even for us, we are an island. So if the sea level goes up, means some of our areas will be under sea. So therefore, our land area will be reduced. Then this is very important. This is the prediction for precipitation, rainfall. Now this is the winter time, or December, January, February. This is June, July, August. Now, if you take the two, I'm just focusing on our area only, right? Now, Sri Lanka here. This is like more green, so somewhere here. So about, this is a precipitation change. That means increase about 20%, 10%, 20%, plus 20 or so. That means during the southwest monsoon, more rain will be there. And of course, we know more rain in the southwest means flooding, landslide, various other problems, right? This is not good for us. And if you go for the winter, let's say December, January, February, our northeast monsoon, where we get rain in the northern and eastern parts of the country, you see it is now brown. That means 20% less. So that means we will have less rain in the northern and eastern side and more rain here. So that's very, very sad situation for us. If you change this, you can flip this, that's very good for us, right? Because our agricultural land should need more rain or water, and here we don't need that much because flooding is there. So therefore, what we see is for our country, we are getting, if this goes as climate comes through, our agricultural base will be drier, dry zone will be drier, and wet zone will be wetter. So that's not so good. So this is a problem with the associated climate change in Sri Lanka. Now, physical impacts, I will quickly go through these. These are the problems: prolonged drought, severe and frequent cyclones. We got a cyclone last year also. High intensity rainfall, floods and storms. We all know what happens when this happens, right? So those are all physical factors. Now, being a developing country, we have been developing country for a long, long time actually. Island nation, Sri Lanka is very much vulnerable to climate change impacts because of these things. Temperature rise will be a problem for us, health, agriculture, many other areas, and also sea level rise, droughts, high intensity rainfall, increased thunder activity, thunder activity kill our people also. And food supply will be a problem. Agriculture, as I said before, rainfall related. Freshwater supply is a problem because now sometimes even calendar river, the seawater intrusion takes place during dry season. So, and loss of biodiversity, human health, all those are problems if the climate change occurs. Agriculture, water resources, human health sectors are the most vulnerable sectors in due to climate change in Sri Lanka. So we need to have a focus on these areas, either to adapt to the situation if we cannot mitigate the climate change. So this is just to give you quickly. This is what happens if the sea level goes. Red areas will be inundated under sea. So therefore, most of our problems, our coastline will be a problem. Land areas will be inundated. 32% of the population live in these areas, especially in the southwestern side. tourism mostly in these areas, and ports, fishery harbors, mainly roads, right? Railroads and highways all are here, and they will be affected. And then the biodiversity, coral reef will be dying, and lagoons, mangroves, all that, because highly populated area in the western, coastal zone, Sri Lanka, south and northwestern part will be a problem, and we need to move, and there will be a lot of economic damage as well, and it will be really a problem for a developing country like ours as a nation, as an island nation. So those are just to give you the problems. So let's look at the rainfall, for example. We need to manage our water mainly, sustainable, because floods and droughts are there. Therefore, if you can manage it somehow, like in King's time, huh, it will be a useful thing. Now, if you take rainfall, now dry zone, we have about 900 millimeters rain per year, annual rainfall. And in the wet zone, we have 5,000 millimeters per year. So we have enough rain. If you take the global average, it's about 750 millimeters globally. So we have about 1,900 millimeters. So if you can manage our water, in a proper way, we be able to manage it. So now I'm giving here China, for example, retain about 70% of rain water in the urban areas. It's called sponge cities, right? We have wetlands. They keep them. For us, what we could do, we have more water in the west, southwest, and less rain in the northwest. And as engineers, can we think of diversion, this excessive water to the needy areas? Maybe from Nilwala to Hambantota, maybe Kalandi to maybe northwestern side or north. Something to think about, right? If you want to manage, those are things, innovation methods that we need to do as engineers. You all also think about it for the benefit of the country. Okay, air pollution due to transport, energy generation, mining, agriculture, industrial process, waste disposal in our country as well, right? This globally also this is there. For us, transport, energy generation is mainly the main factors that increase carbon dioxide in the agriculture, and agriculture also is a problem. So air pollution comes through these actions. And so therefore, if you want to reduce, we need to focus on these areas. Land and soil, of course, we deplete the watershed, deforestation is taking place. Even nowadays, we hear these things. If you deforest, soil erosion takes place. If you have, burned the forest, then, sanitation water bodies, lakes, tanks, because, soil erosion will go and deposit in those areas, water bodies, and the amount of water retention will be less, and that will create problem. And also the fertility of soil declining, and also these are real national problems that we have to think. Now getting back to this, now climate change, United Nations Framework Convention on Climate Change, it was in 1992, Brazil, Rio de Janeiro. Sri Lanka also party to this. We are party to many. So the aim of this international treaty is to stabilize greenhouse gases in the atmosphere at a level that would prevent dangerous man-made anthropogenic interference with the climate system. So that's what the main aim of initiating this UNFCCC. Whether we have achieved this is a problem, because now 20 years ago, 1992, right? More than 20 years ago. Now, then associated, as I said before, we after 20 or more than 20 years negotiation, doing things, we came to Paris in 2050. This agreement is to enhance the implementation of United Nations Framework Convention on Climate Change to strengthen global response to the threat of climate change in the context of, now we come to sustainable development and efforts to eradicate poverty. So now this is very important. This is where we connect to sustainable development. So Paris Agreement focusing on sustainable development by through that process to mitigate or try to work on climate change as well and poverty reduction. So this is very important. So how we go about this also we need to plan. Now Paris Agreement continues. Agreement includes this few points. I'll just give you as a glance. We need to globe needs to to peak greenhouse gas emission as soon as possible and achieve a balance between source and sinks. In other words, amount that we put to the atmosphere, the greenhouse gases, that has to be absorbed. Then it comes to a balance, right? But in a system, you put something in and you take out equal amount, then the system will be in balance. No? That's the basic idea here. Therefore, if you are putting more into the atmosphere, you have to have more sink, maybe vegetation, forest, to absorb that equal amount. So either you reduce emission, increase sink, then only we can balance this, right? And the Paris Agreement also says keep the temperature increase well below 2 degrees centigrade and to pursue efforts to limit to 1.5 degrees. Now, I'm going to tell you how we can do this. Now, if you want the rise to be limited to 2 degrees, the concentration of carbon dioxide or the greenhouse gases should be limited to 450 parts per million. If you exceed that, then the temperature will go beyond 2 degrees. Now, if you want to make it 1.5, then the atmospheric concentration of greenhouse gases or the carbon dioxide, for example, it should be 350 parts per million. That means we have to absorb more from the atmosphere and emit less. I don't know whether we can achieve this because the third world countries, mainly the island nations, are trying and begging the developed world to limit it to 1.5 degrees. That means we have to really take out from the atmosphere more carbon dioxide and reduce the concentration below the present level, right? That is one. Now, in order to do this, the developed world they promised $100 billion a year in climate finance for developing countries by 2020. Now we passed 2020, this is not to be seen, not even close to that, with the commitment for further finance in the future. Okay, but this promise is not achieved yet, but there are some, but not close to this. Okay, right. Now options are available. What are the options available? As I said before, either mitigate, in other words, reduce emission, or if you cannot do anything, plan for the worst. In other words, adaptation. Try to live with it. Like countries like us, we may have to live with it, so we need to plan for it. I compare this as prevention and cure. In medical, medicine, we say prevention is better than cure. That means if you prevent somebody getting sick is much better than once you get sick, you try to cure that person. That means it's costly, time consuming, and it's a real problem. But if it is good if you can prevent it happening. In other words, you be healthy. So same thing here. You mitigate. It is better than adaptation for the whole world. But can we do that? It's a problem. But we need to try to achieve that. Okay. What is mitigation then? This is the whole thing. Now, mitigation is the technical change and substitution that reduce resource input and emissions per unit of output. In other words, we try to reduce emission, and you have to get more from the resource. Resource should not be wasted, right? So several social, economic, and technical policies would be produced and emission reduction with respect to climate change. But really, mitigation means implementing policies to reduce GHG emission and enhance sinks. So this is what is mitigation is. So world has to go in that direction in order to prevent further disaster situation. Now we are talking about sustainable development. Now we are more or less getting to that. We have about we have gone about 1 hour, but let me try to quickly talk about this. Now sustainable development is not just development, not economic development that meets the need of today without compromising the ability of future generations to meet their own needs. So that's the sustainability. Okay, so we need to think about it. We should not destroy anything today and leave nothing for future generation. We need to have think of future generation for their survival as well, for their needs. Now, but we see world is on a path to destruction through human activity, causing rapid resource depletion. In other words, we use more resources than we should, and heavy environment pollution, land, air, all that, which has exceeded Earth threshold capacity. It's a situation where things are getting bad to us. Okay, we should know that there's no survival without sustainability. Now, sustainable development includes 3 independent components. These globally we are talking. These are called triple bottom line: economic issues, social issues, and environmental issues. We should not consider only economic development. We need to think of social well-being and the environment health. In our country, on top of this, if you think how your ancestors lived and our religious base and all that, cultural base, spirituality comes in here. Taking this, we also have to think of our spirituality so that we do things, the way the future is bright for all of us. Okay, let's go through this. Now, at Rio Plus 20 in 2012, after 20 years where the UNFCCC initiated, again we went to Rio in 2012, and there was a document which is called outcome document, the future we want. This was the document that was considered at Rio about just to let you know, more in the whole world is there. 197 countries are coming together and discuss this. So at that place, these sustainable development goals were considered. So this document led to 17 sustainable development goals and 169 targets. These targets are and the goals are action oriented, they are global in nature and universally applicable. Now, indicators are focused on measurable outcomes, should be measurable, and also integrate economic, social, and environmental aspects and recognize their interlinkage. In order to be sustainable, we need to consider all these aspects together, not one separately, not only economic development. So this is the base of sustainable development, which was taken in 2012, and this was linked to climate change in Paris Agreement, I showed you before. So it is very current, and we need to really focus on this. Now, this is the 17 goals. We have poverty, Mostly the first few are social, no poverty, no hunger, good health, quality education, gender equity, clean water and sanitation. All these are, social based. Then renewable energy also there. Then these are like some of the economic oriented, responsible consumption, sustainable cities, uh, innovation and infrastructure. They are more or less economic development. Then we have biological aspects, uh, life below water, life on land, peace and justice, climate action. Climate. This is what we were talking about: climate change, climate action, right? And coming together, all 17 goals are, some are more or less social based, some are economic based, some are environmental based. Now, in detail, we can see here what they talk about. End poverty in all its forms everywhere. I will just read few. Reduce inequality within the among countries. I don't know whether it's happening now. Ensure sustainable consumption and production. And take urgent action to combat climate change and its impacts. So those are there, and many all this. See, ensure healthy lives and promote well-being all at all ages. So if you look at through this, it's all common sense, but we need to really focus on this in order to achieve something. Now, if you go through this process, we see now some are social, environment, economic. If you take social and economic only, we can think of equitable. Then social and environment, there is a bearable situation. There's a level that is bearable. Now, economic and environment, is viable. Environment viable, economic development, right? So, but putting together, three together, we may be able to achieve sustainable development, sustainability. So that's why we all are equally important, not only economic development. Now, if you take these things, as you see, these 17 goals can be divided into three sectors: economy, social, and biosphere, more or less environment. So mainly about 16 for 8. 8 of them are mostly society based. 1, 2, 3, 4, 5. All those are mostly society related. And then biosphere or environment related things are here, right? And then economic related ones are here. So putting all these things, together only, we can think of sustainability. Now, how do you look at this? We have 17 goals, targets. Now, in our country, we had about 51 ministries in the previous government. Now, I don't know how many. There are project ministers, so and so forth. So we need to have system convergence in order to, achieve the sustainability. So we have line agencies, and our government system, we have central environment, we have council councils and local authorities. Now, so all these have to work together. So when you have too many, also it's difficult to work. If you have provincials, you have, environment related things, they do different things. Education is different sometimes. Health is a problem. Nowadays, government is trying to do something, especially health sector. They are going to bring it to the central environment, central government, and things are there. But just to show you how difficult it will be to tackle this. So therefore, we need to really think. Wholesome picture has to be taken up in order to consider the national development. Taking into consideration all these goals and actions, targets. Okay, so major aspects of sustainable development we can consider as consumption and production. If you have, if you can achieve sustainable consumption and sustainable production, and see, consumption, of course, to be sustainable, it will be it should be intelligent consumption. Okay, so if you are intelligent enough to consume and production is sustainable, then we can have sustainable development. Now, we can take different approaches or strategies for sustainable development. These are some of the things. Mainly, as engineers, you need to really focus on these things when you do things. Waste minimization. We should not waste things. Pollution prevention. We need to prevent as much as possible pollution. And we need to think of cleaner production and efficiency, eco-efficiency. And we need to really think of sustainable development goals as we saw before, and resource sustainability. In other words, we need to use resources in a sustainable manner. Sometimes we call force in the loop or circular economy sometimes. Okay, we'll talk about it. Now, resource consumption is actually, now as I said before, we are consuming more than what we need and what the resource can supply. We need to think of ecological footprint. In other words, we have to be mindful of things that we do. Calculations clearly indicate that present population is consuming more than what Earth can provide. So that's the real problem. So therefore, this will lead to resource depletion, degradation of environment, leading to huge anomalies and inequality of life among different societies. City and urban and rural areas, and then rich and poor, and many other things. There's a difference. So we need to really reduce those things. Gaps have to be reduced. So therefore, we are threatening the survival of our future generation. So resource consumption is a problem. We are using more than the Earth can provide us. Okay, so sustainable production is very important. Sustainable production is resource efficient and cleaner production. This is, of course, all can understand this. Resource efficient and cleaner production. That's the main thing that we need to think of when we think of sustainability in production. Okay, this is to show you. Now we see the present production is like this. No, we put energy into the system, we put the raw material into the system, we put maybe water into the system, and we have a production system here, and emits air emissions, pollute water, wastewater, and solid waste. All those go out, and we get a finished goods and services. But what we need to do is, as I said before, these things have to be reduced as much as possible. We put in something, we get something equal to what we put in, so that we can reduce this. This is called production that we need to really aim at. But really what we do is we extract raw material processing. This is an example. We manufacture and we distribute or transport, and end of life you throw it away. So stage of typical life cycle is this. We get resources, finally we throw out something after use, so create garbage. So this has to change now. So resource reduction and achieved through resource decoupling is necessary. So reduce resource intensity, recover and reuse, 3R, reduce or redesign the production, factories and all, and reduce consumption. This is, just reduce. There is a way of reduction, not that we, we can, consume, but there's a way of reduction. We'll see how it is. So these are the things that we need to do in order to do the decoupling of resources. Otherwise, it's going to be a problem in the future. Now, we need to do this, the same thing. If you can close this loop like this, then it is sustainable instead of throwing away, right? So we need to think of this, cycle. We may put in some resources, but we should not throw away much. End of life cycle. If you can, reuse, maintenance of product. This is what we need to really try to do. Okay, but what has happened is actually resource consumption with change of society has increased. Now, good, hunter at the time, the use was about 3 kilos per day per person. But agrarian society increased to 11 kilograms per day. But now industrial society, 44 kilograms per day. High consumption has increased rapidly, and that has created problems like this. Okay, what has happened is now we are producing more and throwing away lot of resources actually. So we need to reduce this. Otherwise, we are like garbage kind. Humankind has become a garbage kind. Okay, so if you can, reverse this to some extent, at least we can be sustainable. If you move in this direction, it is not sustainable at all. Okay, now your waste material should be someone else's raw material. If you can do this, this is wonderful. And development, now say local economic development. Now what happens? We have a linear economy now, where we have natural resources as we make, dispose, and waste. This is what is happening. Technical and biological materials mixed up, energy from finite sources. This is the problem now. So pathway to local development, shift from linear economy to circular economy. So we have to move from this linear economy to circular economy, where we can have technical material and biological material separated, and energy from renewable sources. To do this, of course, it will be circular: make, consume, enrich, make, use, and return. Right? If you have this biological and technical, circular way, then it's a circular economy. To be sustainable, we have to move from this to this, from linear to circular. So our planning, our action should be more towards this, not this, right? So that's the main thing, main message here. Okay, the basic principle for circular economy: design out waste, build resilience through diversity, rely on energy from renewable sources, think in system, not just one thing, whole system. Waste is food. In other words, we should not waste. So that's the message. Okay, then we talk about sustainable consumption. Sustainable consumption, intelligent consumption. As I said, it is intelligent consumption we should have. We should shed away the emotional consumption pattern. But we are now consumed emotionally, not intelligent. Okay, so therefore, to be sustainable, we'll have to be intelligent in consuming things. Okay, so factors affecting our consumption choices: sometimes culture, subculture, social class. That's why. Then sometimes the groups, family, role and status. To have a status, we have to have this, that, a finished product. When you go to supermarket, you buy things that are not so important, not necessary, and you don't buy intelligently. Sometimes you buy things because of the problems, family pressures, and then sometimes the personal, age and life cycle stage, economic circumstances. If you have more money, you buy things more and throw away. Lifestyle, uh, and sometimes the opinion of others, demography, personality, and self-concept. So all this leads to buying more things and consume more, and it's not sustainable. Then sometimes psychological, perception you have. You think now, for example, I'll give you one example. Now you want some medicine, you go and buy, but SPC medicine is cheap, same medicine. You see the advertisement, but my personal experience. If you go to a private pharmacy, if you ask SPC is there and the other thing is there, sometimes 1:100 difference. You know, uh, 3 rupee thing is maybe 25 or 50 rupees, but still they will say, "Oh, this is good. This is foreign. This is from Australia. This is from UK, and so on." And attitude is towards that. You buy the expensive one, the local one is cheap, but you don't buy that. So that's a problem, psychological problem. So if you move in that direction, we won't be able to achieve sustainability at all. So I am just giving one example. You can think of many examples like that. Okay, why you are going to more, use more, consume more, right? Mainly because sometimes these things it is advertisement. If you look at TV advertisement, radio advertisement, they are not real actually. You should know, intelligent people should know. They put up so many things into the and you are you know uh, attracted to those. Maybe children are attracted to those. Children will tell the others, they want that and this and that. So brand loyalty, then product promotions is there, then peer pressure is there. Mainly, these things lead the society for more consumption. So therefore, it is not sustainable. It is not intelligent. Therefore, I have seen only in this country. I have lived in many countries. Actually, I have visited many countries, but I don't see this type of advertisement. That the consumers or the society also influencing advertisement. If you put something on that as an advertisement, human society, the pressure groups can challenge that. It's not happening in this country, but other countries happen. Developed world is happening. So you cannot just publish, giving false information. But things have to happen in this country. I don't know what is happening, because I can see I'm frustrated looking at those things, but nothing happens. But we need to, if we are thinking properly, we can be intelligent enough. Okay, now our economy is brown actually. We are polluting the surrounding. Air is polluted. There's no law. Laws are not properly implemented. Land, unlimited soil waste dumped openly. Land is polluted, and the water is polluted. Discharge of wastewater to rivers, and many other things. Air, land, water is all polluted. Our economy is brown mainly because our industry is also not properly organized or properly controlled. Those are real problem for development as well as sustainability. Okay, our agriculture, for example, survival actually. Our agriculture is suicidal. You know, natural capital is depleted, reducing the genetic diversity, because we have gone to monocultures, killing polluting agents, killing soils, get kills all organism in soil. So social capital is depleted, and we don't have networks. I can think of many other things in the country. Now, if you go to this lost network in agriculture, is something, because if you go to a rural area some 50, 60 years ago, there were the farmers were together. They cultivate things. For example, a paddy field. everybody get together and do the things. You know, you don't go individually. So you work in one place. They are called under good or not under attam. That means, you know, we work in one field, all get together, all farmers get together and work in one field today, tomorrow, all go to the next field, so on. So all are united. There was a good network, and you know, they were united, and you know, we had a very good culture, and we didn't have rich and poor separating like this. Now, but today it's a business. You pay people to work, right? And you don't know the things, you just work for the wage. And it was, you know, not like that before. So we have lost our network, and therefore, really speaking, we had our ancestors had a real life, sustainable life living pattern, but we have lost that. And I don't know how to revive that, but at least there are things that we can do. Now, traditional methods of pest control are adequate. I think government and some of the agencies are pushing for this. Grains have high protein contents instead of, you know, more animal husbandry. You know, there may be other ways of getting protein and other things that we needed. And also we should you know, avoid you know, sugary and oily food, because it's important for our health. Save the you know, degraded by sugarcane and, you know, various other things. You know, if you live in harmony with nature, probably we can achieve sustainability, but not as, you know, we lived before, but with the new development. You know, think positively. We can manage things so that it will be sustainable. That's what we, you know, engineers or, you know, educators, you know, learned people really have to think about this. Otherwise, you know, we will kill ourselves and the present future generation as well. Okay, now I want to just you know, focus on this also, mainly because if the temperature goes up, we will have to cool ourselves, right? So how do you do that? We need to have air conditioning, maybe at least a fan. Now, you know, if you live in you know, suburban area or cities, without a, you know, at least a fan, you won't be able to sleep. No? So air conditioning, if you have money, you will put an air conditioner, right? So therefore, cooling is also very important because it needs energy. So we have to generate energy. If you generate more energy, means, you know, in fossil fuel based energy generation will create problems, because more pollution, more greenhouse gas get into the atmosphere, and it'll increase further. This you know, feedback process, and the cycle will go on. More energy means more pollution, more heating, and more energy needed for cooling. So therefore, I just want to highlight some of the things here. Cooling is the removal of heat, usually resulting in a lower temperature and of phase change. Temperature lowering achieved by any other means may also call cooling. Cooling is temperature removing heat and lowering the temperature. That's what is cooling. Now, devices that we use, heat exchangers, radiators in automobiles, for example, then cooling towers, large industrial plant, and power station, including ventilation fans, etc. Those are the ways that we cool. These are, you know, industrial ways of cooling. Now we use coolant or refrigerant in these applications. Now these are mainly refrigerant that we use, HFCs, HCFCs. Now these are all HFC. Now why I put this? We have to according to the Montreal Protocol, now there's an amendment called Kigali Amendment. Under Kigali Amendment, every country has to have a cooling pad. Why? As I showed you before, this HFC, CFC we have replaced. No, CFC was replaced by HFC and HCFCs, but they are very strong greenhouse gases. Why we shift from CFC to HFC? Because CFC was ozone depleting. In the meantime, it was a greenhouse gas. Under the Montreal Protocol, aim was to save the ozone layer, and therefore ozone depleting CFCs were removed and substitution was HFC. HFC was not a ozone depleting substance, and therefore under Montreal Protocol, CFC was replaced by HFC because HFC was a non-ozone depleting substance. But now we see, even those days we knew this and we were pushing for this, but finally after 20 years or so negotiating, now they have come up, 2016, the Kigali Amendment. Under Kigali Amendment, these refrigerants has to be phased down. So all HFC has to be phased down, but their global potential is this much. If you take carbon dioxide is 1, these things are now 134A, 1430. This is the main refrigerant used in mobile air conditioning, domestic and industrial heating, and central AC transport refrigerant. All that use this one, and many other things also used in air conditioning and refrigeration. Therefore, we need to really focus on this because as a country, we have to put up the cooling plan. We have developed one, and there's a policy developed now. So therefore, we need to, especially engineers, if you are Prof engineers who are dealing with this, please take into consideration this. There's also mechanical engineers, maybe civil engineers, electrical engineers who also have to consider this. Now, under the Kigali Amendment, these are the things. Now, there's a baseline. We are here, developing countries, group 1, middle ambient temperature. So we are here. So we need, we are using baseline 2020 and these 3 years. And then we have to, we take average of these HFC and HCFC as baseline according to this. And we have to freeze by 2024 this, and then we have to reduce like this. So this is just, I won't go into details, but just to give you an indication that these things have to be reduced. We are party to Kigali Amendment as well. Whole world has to do this. Now, therefore, now this is what I said before. CFC high ODP, ozone depleting potential is high, and they are high global warming potential. CFCs were replaced with this. No ODP, that's why mainly this was taken up, HFC, but these are high global warming potential. Now we are looking for HFOs, no ODP, no ozone depleting potential, lower GWP. Okay, and this is yellow, this is better hydrocarbons. No ODP, no GDP. So it's better that we can go for this. There are problems with hydrocarbon. They are flammable, and system has to be there, especially in movable ones. These are using of these things are sometimes difficult. So they have to have a innovative method of using this. So globally we are working on this. Locally also we have to adapt to these things in order to phase out HFCs and LFCs. Why cooling matters, of course, we know. For example, now with this COVID vaccination, we have to keep them in cool area, cool place. So therefore cooling is very, very important. Adequate space cooling, air conditioning is key to human comfort, production and economic development. We need that. Then the operating theaters, high-tech factories, research laboratories, data centers, a few example, consistent and precise temperature and humidity control to function. Now even the vaccines also like that. Air conditioners are an invaluable tool to help meet these needs. Okay. Then of course cold chains. Cold chains are essential to ensure that the farmers produce their fruits, vegetables, and dairy, poultry, meat, and fishermen's catch and medication can be reached consumers without premature loss and with quality or the freshness. So cold chains are also important. In that also we have to use refrigerant. Then cold chain is a temperature control supply chain of refrigerator storage from harvest to final distribution until the product is consumed. So these are very important areas. Therefore, cooling is also a matter for developing country as well. Now, national cooling plan, I said before, it's a national strategy for environment protection and climate change mitigation through the development of minimum energy efficiency performance standard. And we have to improve energy efficiency and also fast, most cost-effective and cleanest ways of saving additional energy for sustainable development. We have to save energy, right? So therefore, we have to improve energy efficiency of systems, equipment, so on. So national cooling plans bring together policy and program consideration across the range of stakeholders, emission, energy efficiency, adaptation. So this is, you have to be aware of this. Everybody has to be in here as stakeholders. We need global warming and related climate have created serious problems like drastic temperature increase and irregular weather patterns, floods, and so on. Under UNEP and the Paris Agreement, GHG reduction is must to keep the temperature under control. Cooling situation is air conditioning, refrigeration need at a manageable level and in an efficient manner by using latest energy efficient methods and also natural ventilation. Now, building construction and all engineers need to know how to use natural ventilation, natural lights, maybe fans, energy efficient environment friendly building designs. Okay, it's a must. Natural filtration is also the technology has to be improved. So therefore, try to reduce consumption of energy. And so we have stakeholders coming to various areas, equipment manufacturers, cooling industry, and users, end users, energy, transport, agriculture, housing, urban development, all has to work in the cooling areas as well, and other areas as well, of course. NDC is not limited to group. Now we have also something called national determined contribution for mitigating climate change. Now we also in this country we have because it's a must under Paris Agreement. Every country has to think of national contribution. So in DCs, this is the heart of Paris Agreement and achieve the in order to achieve these long-term goals. NDCs embedded effort by each country to reduce national emission and adapt to impact of climate change. So NDCs are also something each and every country has to look. We also have in this country, we have identified some NDCs. So they are like long-term energy plan. We have to think of reducing pollution, maximum use of alternative energy, and achieve relevant sustainable development goal. So we, as a country, we need to achieve that. Sri Lanka climate, action plan, cooling action plans. We think of these: space cooling, current and future view. We have projected, and when we do this, we took the current status and the projections are made taking into consideration current and the future needs. Okay, if you are developing, we may need more cooling, for example. Then, of course, how do you manage to get the necessary energy? Okay, so we need to develop cold chain refrigeration, because in this country, you all know, maybe heard about this. The production is lost on the way because at the, say, for example, agricultural products, maybe more than one third is lost. Okay, transportation while harvesting, and there's no proper storage. Transportation is also there. So therefore, there's a lot of loss. If you can reduce the loss, we can achieve sustainability. Then, of course, refrigeration air conditioner sector, we have to think. So if you have a cold chain system well developed, we can reduce the loss of especially food, for example, harvest. Energy efficiency, positive recommendations on energy efficiency, we are in the plan, we are giving that, right, for improvement, where we can improve the efficiency, and of course, alternative technology to secure environment and social benefits. So those are the things. If you look at, get involved in this pooling plan also in the future, so that in your workplace or in a company or wherever, if you are in a policy arena, you also have a role to play. Okay, this is some projected annual energy consumption, just to show you one or two slides. This is what we got. Now, blue is now business as usual. If you go, this is how it is going to be. This is called reference scenario. But we are now projecting this way, taking into consideration energy efficiency scenario. Maybe 15,000, 8,000 we reduce by this time. Gradual reduction can be achieved if you think of sustainable way of doing things. So we are promoting this, not this. So, but in order to achieve, all have to contribute. You all have to contribute to achieve this. Then annual energy consumption in refrigerant sector, business as usual. Is this, in different areas: dairy, fisheries, poultry, retail and supermarkets. This mostly retail and supermarket by 2030 will be like this, right? And dairy will be like this, the first bar. Then poultry, fishery is the lowest here, greenish yellow. When all these things are, we have estimated like this. If you are going as business as usual with time. Now we took this and put these projections. But now energy annual energy consumption interventions now here. It is like this for different sectors, right? Annual energy consumption will be like this. Okay, so therefore we'll have to think of how we reduce the energy consumption in time to come. Now, coming back to this, now we also consider this in our cooling plan, indigenous knowledge and research, right? Now, our ancestors in Sri Lanka have developed their own cultural practices and lifestyle that were the harmony with nature, natural ways of things. Sri Lanka has long history of indigenous knowledge evolved over the centuries. Now traditional methods are there. For example, sun drying, for example, to keep things for a long period. Vegetable, mushroom, jackfruit, and things like that, they kept for long periods by sun drying. But today we are not doing that. But that may be something, because now it is free. If you have, you don't have to waste generated energy. Then smoking, for example, meat and fish. Then also like pickles and fermented, salted, pickled ones. So fish and meat pickled, sometimes buried in sand, ginger, seeds, jam, and all that, right? I don't know whether you can do that. Now say kurukal, that means the method used prevents meat. Now see atua, dummas, bis, Paddy and Kuraka, we kept there, right? But then now we don't have a Bisa, no. We don't have a Bisa also. So anyway, but these things are, things that we have been doing, but we have thrown away all this and moved to a mechanized or energy consuming ways of keeping things. But I'm not preaching that we have to go back to this, but there are things that we can use and use this traditional knowledge with the new technology and try to reduce energy consumption and try to be sustainable. That's all I'm saying. So we are talking about this also in the cooling plan. So think about it. Now for builders, now of course we know we learn things from nature. No, I can give enough examples. Even the bullet train was designed like that. Many things we learn from nature. Even the airplane, even the fire, many things. Now this is one example. And hill building design. Now here the ants, nature, they have enough ventilation here. They built like this, but there are now buildings using that. So it's a way now it will be less energy consuming if you build like this, right? Try to use maximum ventilation, natural ventilation. Of course, there may be problems, and also natural light. So the energy consumption will be less. So architectural designs have to be like that. Maybe some of you are architect that we work in the field. Think about it. Now, the national determination, now that's only one thing I gave you. I can give you enough example. There's no time to discuss all that. I'm quickly going through, but you can think of, not only this, many other things are there, right? Then NDCs also there. NDCs are primary means of government to communicate to internationally what step they take to address climate change and sustainable development in the country. So we have done that. I think the Environment Ministry has given this now, but we need to achieve that because now we cannot just give the thing that we are going to do this and wait. So therefore we have to do. Now basically adaptation in disease are human health, food security, in agriculture, livestock and all, then water, irrigation, coastal and marine, biodiversity, urban, city planning and human settlement, tourism and recreation. These are the areas of the topics that the NDCs are based on. So therefore, if you consider these areas, of course, it can be sustainable and mitigation will take place if you consider these things. I don't have time to go into details of these things. Therefore, just think about it. Okay, there may be base of now human health, for example. If you your food consumption is managed intentionally and intelligently, intelligent consumption will be useful. So many other things are there. Energy sector is very important. Establishment of solar power plants. That some of this happening in this country. Solar power plants. We had something. Large scale wind power plants. Recently we had the manna, right? Biomass plant. Recently it was we had this. Then mini hydropower plants. Demand side management is also something that we could do. Sustainable Development Authority is taking action. Then converting existing fuel oil based power plants to LNG. Very recently this happened. You all know. All this are in the news now. Okay, these are ways that energy sector, so strengthening sustainable energy related policies also there. So these are some things that we have been advocating, and it's happy to know that some of these things are happening now, right? So we are moving in the right direction. Transport sector, of course, not so happy. I'm not so happy. E-mobility, electric mobility is not taking place. That will actually, reduce the emission. No? Reduce energy used by vehicles. Do that if you go for e-mobility. That's very good. Read energy in ACs. So we need to find environmental efficient. They are energy efficient also. Improve energy efficiency equipment. There are something called, we were talking about highway solarization. It's a win-win situation, but things are not happening. I'm not happy on that. E-mobility is also not happy as we plan. It is not happening, but as hopefully in the future, many of the developed world is doing. Where they don't have even renewable energy like solar energy that much. Those countries are temperate food countries are moving in that direction. There are maybe some problems with that, but we need to overcome those and move in that direction. Uh, that's environment friendly and also energy. Less energy consumed areas have to be considered. Now, for example, this is actually Brazil. They are using biogas to operate buses like this. They have power stations, only biogas are there. Many countries, I don't know whether we can do that, but at least we have to move in that direction. Then eco-friendly design, for example, for example, these are agri-based plastic. Plastic is a problem, no? It's a waste. But then now see, think of an ice cream cone. You eat ice cream and eat the cone as well. If you have utensils like this made with algae and edible, you can, you will throw away this after you eat your food parcel. You will maybe consume this also, and there won't be any garbage collected. Right, and also this is something also zero detergent washing. This is use ultra waves and electrolyte the water, and therefore it will wash your clothes. Power is enhanced by synergy with the ultrasonic waves to create zero detergent washing. So there are, without detergent we can wash, right? So that's a clean way of doing things. You don't put detergent into the environment, harmful and detergent. Then copier, decopier, you can erase the toner and reuse it, right? There are methods for doing this. Technology for removing toner of copy paper. There are companies doing this. So it's called decopying. So copying machines, some of these paper wasted, good paper after, copying or something, you throw away. But if you decopy, you can reuse it. That's, you use natural resources in hash, and also the, ink is collected. That's one way of, it's a cleaner production actually. And then, of course, development. I'm coming towards the end now. Development of human society accelerated. This is what has happened. Demand for resources. You take food, for example. Meat consumption has gone up with the development. Now, per capita income goes up, and the meat consumption goes up, and it's going like this. More development, more meat, right? Why not this? Okay, you can go this. Okay, then maybe you are living with harmony, less energy, less water consumed. If you take production, for example, develop a human society, demand for resources, how many food. To produce 1 kilogram of food of different varieties, water usage. Potatoes, this much, wheat 900, okay, rice 1910, okay, water liters. But if you take chicken, 3500, beef 100,000 liters of water to produce 1 kilogram of meat, beef. So it's a water problem there. But if you take food, energy required for production, 1 pound of these corn, milk, chicken, this, and because water and energy is the main thing. So if you take, we saw water, how much is used, energy requirement, and for beef 30 as compared to maybe 1 or 2 for corn and chicken and milk and things like that. So therefore, we really have to think energy reduction, energy and water usage. So that's all I had. Now we have a few minutes, maybe almost 7:20, 25 or so. So now let me close this. And are you all are there? Hello.
Yes, sir.
Yes, sir.
Yeah. Now, yeah, you
Yes.
can. If you have anything, you can of course.
Yes, sir. There's a question.
Yeah.
What are the Millennium Consumption Goals that you covered? Oh, one thing missing. Millennium Consumption Goals.
Millennium. No, I didn't cover that. Millennium goals are there for consumption. Also there. So what is that? Millennium is this century, no, right? So before that, now the latest thing is the sustainable development goals. In the sustainable development goals, we have consumption and production. Okay, that is what I was talking about. Because now, within this century, actually by 2050, if you want to mitigate, you have to reduce. I didn't talk about it, but then really speaking, under Paris Agreement, we need to reduce emission as soon as possible. We have to reach the peak and we have to go down in the emission, right? In order to do that, we have to think of this sustainable production and consumption, intelligent consumption. I said so. If you achieve these sustainable development goals, millennium goals will be achieved. Okay, so therefore, now the present action is more oriented towards sustainable development. These 17 goals. Okay, is that okay? Hello.
Okay.
Yes,
Thank you.
Any other point to raise? I will remove the yes. Anybody wants to? Hello.
Yes, in this kind of question, what extent, up to what extent we want to write or elaborate, that means the words or number of pages?
Now in the question paper, it will be given actually. If you look at the previous question papers, you will get the type of questions there and the answers expected, and the question paper give you all the instructions. Just look at the previous papers. Is available no for you all? Can you all look at the previous papers?
yes.
Yes, sir.
Yes.
So it will be same type. So just practice with the older question papers. There won't be any change in the question paper this time as well. So my advice is to practice with the older question papers and prepare for questions to come. Only thing is that now I am more emphasis was given on sustainability. And I said from the beginning, climate change has an influence on the development, of course, you know that. And then in order to achieve sustainable development, we have to think of energy of sustainable consumption. Okay, now in good old days we said too much consumption is also problematic. Now this is something like you move in the middle path. If you all, some of you are Buddhist, maybe think of Buddhist philosophy and our cultural heritage is that, no. So too much consumption leads to many problems, health problems, many other problems as well. Economic problems are also there. So the basic idea is intelligent consumption and resource management, reduce waste. So that's my focus, because if you increase waste means creating problems for the environment and also increasing the problem for climate. Okay, so if you want to mitigate or adapt to climate, we need to think of intelligent consumption, one thing, and the production base has to be changed. Now government is moving in that direction in a great way. I showed you the energy base, because we need to go from fuel-based system to natural-based systems, energy generation as well as other activities. Therefore, we have to move towards nature, be more green rather than brown, move away from brown to green, move away from pollution to pollution-free production, move from heavy consumption to sustainable and intelligent consumption, and production. Mainly as engineers, you have to think of all these fields: housing, cooling, refrigeration, transport sector, right? And also cold chains to save, reduce waste, right? So if you think of on those lines, I think you get a good picture what we were talking about today. Okay.
Okay, sir.
Okay.
Okay, sir.
Okay. Time is up then. Shall we stop then? Thank you
Okay,
all
sir. Thank
for
you.
listening. Thank you all. Now we have 40
sir.
participants. That was very good.
Thank you, sir.
Yeah, you were there with me throughout, I hope. And good luck for the exam. And hopefully these problems will be over. One day we will meet again, face to face. Thank you.
Okay, sir.
Okay,
So
thank
can
you
you
very
share
much.
your mobile number, contact number?
Yeah, it is with you. Can talk to. You want me to
Okay,
give it
sir.
to you now? No.
Okay, sir. Okay,
If
thank
you
you.
talk to office,
Okay,
they
we'll
have
get,
all
sir.
the details.
We'll
Yeah?
get, sir. Thank you.
Yeah,
Thank you.
thank you.